Welcome to my YouTube channel Statisticians Club. I hope everyone is fine. Please subscribe the channel, also press bell icon to receive latest videos. To our today's topic is important aspect about correlation. Please focus on blue words. These are the most important ideas to understand the whole concept. So let's start. Correlation makes no difference among independent and dependent variable. It makes no distinction which variables you call x and which you call y in calculating the correlation. We can say that if we want to correlation among two variables, suppose one variable is height and other is weight, we can assume either one variable height as x or y, or weight or the variable weight named as x and y. This thing is not matter which variable is x and which variable is y to determine the correlation among the among the variables. Next point, correlation wants that both variables to be quantitative. We cannot calculate a correlation between income of a group of people and what city they live. Suppose we have a population of 10 people with different income, and each person live in which city. We cannot find their correlation because income is the quantitative variable and city lived is the categorical variable or qualitative variable. So with the help of correlation we cannot find their relationship. So it is necessary to determine the correlation that both variables should be quantitative nature. Next, because correlation uses standardized values of the observation and R does not change when we change the unit of measurement, x, y or both. For example, measuring height in inches rather than in centimeters and weight in pounds rather than in kilograms does not change the correlation between height and weight. Correlation is independent of unit of measurement. It is just a number. To understand this whole concept, if we have quantitative values for any variable x and y, to find the correlation, first step is we convert our original observation into standardized values, x minus x bar over standard deviation of x, and for y, y minus y bar over standard deviation of y. So after conversion into standardized values, and if our height is in inches and weight in is pound, its unit does not matter because we convert in standardized form, and standardized form give us result only which standard deviation above mean or below mean. So due to this reason, correlation has no unit of measurement. Positive correlation show positive association and negative correlation shows the negative association. If our x and y variables both are positive, then their association or their correlation will be positive. If these x and y variables are negative, then their association will be negative. Correlation are always a number between -1 and +1. The range of correlation coefficient is from -1 to +1. R near 0 indicates a very weak linear relationship. The strength of linear relationship increases as R moves away from 0 towards either -1 or +1. It means we can say that if R is close to -1 or +1, it indicates point in scatter plot lies close to the straight line, and extreme values R is equal to -1 and R is equal to +1 occur only in case of perfect linear relationship among the variables, when the points lies exactly on the straight line in a scatter plot. Next, correlation measures the strength of linear relationship between two variables. Correlation does not describe curved relationship between variables, no matter how strong they are. So with the help of correlation, we simply measure the linear relationship among the variables, not the non-linear relationship or curved relationship. Like the mean and standard deviation, correlation is not resistant. R is strongly affected by few outlying observations. So be careful applying R in the presence of outlier when the outlying observations appear in scatter plot. Thanks for watching.